on my side, I'm always paranoid that we're gonna be streaming forever and no one will see it. All right, there we are. Cool, cool, cool. All right, so let's start up for today. Today is July 20th. We've got our issue up for the agenda. I even created a cool little label for agendas. So, we're kind of a big deal now. Kind of a big deal. So, yeah. So, if folks haven't been on the stream before, this is all about learning and writing Go. Um, so, actually, I discovered some other fine folks on Twitch, live coding, that are also streaming and learning Go. So, I thought that was awesome. So, yeah, if this is your first time here, welcome. I'm Aaron. I do a lot of Go. Jennifer, introduce yourself.
Hi, I'm Jennifer. I work at Microsoft in the advocacy org on open source. I'm learning Go, and this is a fun process.
And I just want to say, working with Jennifer, both on this stream and elsewhere, is really awesome. Really a pleasure. I think we have two different styles of learning that go pretty well together. Like we kind of, I guess, feed off of each other's learning styles, and uh, yeah, it's fun. It's especially fun on this stream for sure. So
I'm having a blast. It's definitely it's one of those things where it's intense vulnerability to share how your brain works. I don't know if you saw that uh, Erica Joy Baker poll about would you share your naked thoughts or your naked body on our website.
naked
That's a
thoughts,
really tough one
not
because
tough for me. Naked
because like
thoughts.
yeah, no, I that's what I voted for too because I'm like, you know what, I am doing that vulnerability here. Like learning is interesting, and
Yeah.
I too think that it like I'm having a blast working with you. Thank you so much for your awesomeness and
Thank you for being here.
patienceness.
Yeah, patienceness. Yeah, that's a good one.
Patienceness.
Yeah. So I actually was watching Eric.dev earlier. So let me see if I can close that. I guess Twitch is not. Oh well, Twitch is not cooperating. But Eric.dev is another one of our coworkers who streams a bunch. He streams Go. He streams some IoT stuff. He streams microcontrollers and embedded. So he's streaming right now. So if you don't like the cut of our jib, if you're not into what we're doing, go over to watch Eric.dev. So yeah. So what are we going to do today? We are going to write some HTTP server magic and we're going to test it. We're going to write some tests for it too. So all of that code, oh, it looks like Microsoft Developer is also streaming. We got a lot of streams going on today, which is super cool. So those might pop up as we go. That's cool. So yeah, once again, if you don't like me or Eric.dev, you have a third option. So yeah. So before we get started, I just want to repeat, this is a extremely collaborative session. If you saw me on Friday or you've seen me and Jennifer on any of the Monday and Wednesday streams, all comments are welcome. Me and Jennifer, we personally go on tangents. Other tangents from comments in the chat are always welcome too. No, never say sorry for your questions. Never say sorry for your comments. All is good as long as folks are following the code of conduct. So we will start down the road of writing an HTTP server, and then we will start down the road of testing it. I think we'll do kind of both at the same time, sort of. Like we'll take a little step of writing the thing, and then we'll take a little step of testing, and then we'll go back to writing it, and then we'll go back to testing it, and sort of back and forth. So
I
yeah.
feel like you should be doing that in a sing song voice. Then we'll write some, and then we'll test some, and we'll be. Let's go.
Oh yeah,
Yeah,
yeah.
we need to get some music going on. Maybe Brian Kettleson can write us a little song.
That sounds great. We'll ask him. We'll ask him after the stream today. Yeah, yeah. So I streamed on Friday for like two hours, like almost 2.5 hours. So my voice is still hoarse. So I'll try to speak really softly right into the
Oh,
mic like
please
that.
don't, please don't, please don't don't do the soft voice. Just do your normal
It's
voice.
creepy. Yeah, it's creepy.
It's not that it's creepy. It's just
Creepy. It's not creepy. It's just creepy.
it's just not the right vibe. Or
That's fair. Yeah, that's fair. Well, I will speak a little
we're not
softer.
here for the sleepy time meditation. We're here
It's
for the
like
bright eye Monday morning fun
that's fair.
times.
Yeah, that's fair. All right, let's open up the project. So yeah, like Jennifer said, if you've got topic ideas for later, for like a future stream, this is the repo to go to. It's github/OSSCDA/let's go stream. Hit the issues tab and just create a new issue. Title it like I want to see X. That's totally cool. Jennifer dropped the links in the chat already, so check that out. All topics related to Go are totally welcome. So check it out. Don't be shy. If you've got an issue, you're just beginning Go or just beginning programming, that's fair game. If you want to see something super, super intense, really, really intense Go, or even something kind of related to Go, we will get to it. We just may not get to it right away because we're still learning.
So I saw someone mention, I don't want to reveal their name, on the Twitter has said, I am quiet. Is the balance of our voices okay for people watching? If you want to just add a comment in the message
Yeah, please
field.
do.
We are trying to figure out our sound issues because we just realized last week that there was some not awesome echo-ness. So if there's
Yes.
any issue with my sound, please do let me know.
Yes, please. We're kind of learning the streaming, all the streaming things. So, yeah. That's why you see me with headphones in addition now to Jennifer. We learned that lesson for sure.
I Can you turn my volume up a little bit, Aaron?
I think so. How do I?
Because I actually just unmuted the stream and I can hear I am very quiet.
How about now?
Test, test, test.
Oh,
Okay, that's better.
oh, weird. Now I can only hear you through my external speakers. I have to figure this one out. Maybe I can turn you up via... let's see. Control audio via OBS. I have never controlled audio via OBS before. Anyway, maybe we can roll with this for a while and see what happens. Yeah, let's try it. We'll see. Okay, let's get into it. We're going to open up our project. Did I do that already? I did that already, I think. Yeah, I did that already. Jennifer, are you sounding better on your side?
I'll check one more time.
Okay.
Yeah, I think so.
Okay, sweet. So, we already did in this project, we did some stuff with linting and static analysis. So I'm basically going to leave it. And I'm just going to write, we may have to delete some of the code. You know what? Maybe we should we should have a different main.go. How's that sound?
I think that's a good idea.
Okay. So I'll just create a new folder.
So I get to hear the echo of my own voice. Just so
Oh boy. Okay.
you know.
Let's see if I can oh boy. Create output projector.
So while you're messing with that, can we talk about what we're gonna build?
Yeah, for sure. So we are going to take the standard library. Let me try this. So we're going to take the standard library and we are going to write an HTTP server directly from the standard library. So we're not going to pull in any other third-party dependencies or anything like that. And, well, let me just do this. We are not going to pull in any third-party dependencies to write this thing or anything like that. And then from there, we're going to test the same thing that we just wrote with, again, with the testing facilities that are in the standard library as well. So this is all available just out of the box with Go 1.14. And it's all like documented really well, I think, in the like public documentation, which we'll also show. And really, it's really writing functions. That's the main thing that we're basically going to do. We're going to be writing functions that take in certain HTTP things, so like requests and responses and things like that. And then for the tests, we're going to be writing functions that have a really specific name and take in a specific testing helper. And then we're going to be calling that testing helper to indicate, hey, I want to make sure this is equal to this. And if it's not, then I want to fail this thing.
Okay, so I'm going to be super annoying and I'm going to put on my what are we doing hats, because what are we doing, Aaron? What are we doing? We're building a web server. What does that even mean?
We're gonna let me say it simpler than a web server.
Yes.
Um, we're gonna build we're basically gonna build a website. Is that better?
No. So
Hmm.
if we think about so I'm going to be annoying. I'm so sorry.
No, it's fine.
I'm not being annoying. I feel like we talk about things and then we expect everyone to be on the same page, like what a web server is.
Uh-huh.
So a web server, we think of a web server like Apache or Nginx, but like you don't have to have a complex
Oh,
application to have a web server. So what is the core essentials of a web server? So if we were to write
okay.
a test, like what is it going to actually test to know that we're doing what we say we're going to do? So it's going to be a process that runs, right? And
Mm-hmm.
it's going to need some way of accepting connections and returning back a response, right?
Mm-hmm. Yeah, and it's gonna be HTTP in and HTTP back out.
Okay, so I'm just going to I don't know. I'm gonna mute myself while I type this so I don't get distracting.
Cool.
But so
Uh-oh. Oh yeah, you just muted yourself. We are I'm on the edge of streaming knowledge right now, so um I thought that I just lost Jennifer's connection. So while she's typing, I'm going to create a new folder and I'm going to call it HTTP server. Let's do all one word. HTTP server. So I'm going to create kind of the same structure. I'm going to start with kind of the same structure as we see here. I'm not going to have a git ignore or a go.mod or a license or a readme. So I'm just going to do the Go file, just the main.go. We're going to get into the main dot or main underscore test.go a little bit later. So I just said we're going to have the same structure. That's totally it's totally opposite. We're just going to take the main.go actually. So we've seen the really, really basics of main.go. We call it package main. We've got a func main, and that's it.
cool. So that is like the bare essentials that we need to write a Go program.
Exactly. So the
Cool.
code that starts running right away when you build and run your app, no matter what kind of app it is. It can be a server, like an HTTP server that takes the requests and responses, or it could be a CLI, like a command line tool, or it can be kind of like a script that does some special DevOps work, or really pick your poison. It can be all kinds of different things because Go is kind of a general purpose language. So no matter what kind of program it is, it starts right here on line 4. So, Jennifer, should we start writing HTTP logic? Or what do you think? What should we do first?
Well, what is the what is like? How do we make this? How do we make this stay up? Is that part of?
Mm-hmm. It's part of, yeah, part of the built-in. So I want to, Oadia, the mod file has 3 purposes. So right here, if we go in, the mod file is usually there's one at the top of your whole repo. And the mod file on line 1, it specifies what is the name of your program, essentially. So you can have multiple of them in the repo, but most of the time for a medium-sized repo or smaller, there's just one at the top. So it's got that, the name. It has the minimum version of Go that you should be running to build this thing. And then it can also have the dependencies, the third-party dependencies. So that would look like this. Require, and then a parentheses, and then, dependency 1, dependency 2, dependency 3, however many there are. And then there'd be a close, and then that would be it. So, by the way, thanks for joining, Audio. And Siva, welcome back. It's great to have you. Thanks for the subscribe. Really appreciate that one too. So, with that, so Jennifer, back to your question. How do we get it to stay up? There is an HTTP package. And actually, let me import that. So we do import net HTTP, just like that. Whoops. And when I save the file, it detects that it's not used. So I'm not going to save the file just yet.
And so what is that? What functionality is that giving us?
So let's hop over to the documentation on the Go documentation site, and we can check out all the things that it does for us. Is that cool?
That sounds awesome.
All right. So reminder, the documentation site is at pkg.go.dev. There is an older version of this site called godoc.org. That's here. But you can see they recommend it. I really recommend this new one as well. So if you ever see godoc.org, just substitute it in your mind with the new one. So I'm going to close that out, and let's check out pkg.go.dev. Yeah, your dog's having a morning. Your dog wants to stream some Go as well, I think, Jennifer.
He's very not happy with the construction across the street.
Oh, okay. Fair enough. Yeah. So Oadia, I mentioned just a second ago that you put your dependencies here in go.mod. You don't need to put the standard library dependencies that ship built into Go. So this is one of the standard library dependencies, HTTP.
And you can see it up there at the top where it says standard library
Exactly.
or next to the license.
Exactly. So if you click on this, you can see the README for Go, basically. This is the front page of the GitHub repository for Go. Then if you click over to packages, this is everything in the standard library. Like absolutely everything you find in the standard library. And there's ours, what we want to use right here, net/HTTP. So let's check this out. We have an overview, and this is kind of the structure of all packages, standard library and third party. We've got an overview. It says approximately what it is. So package HTTP provides HTTP client and server implementations. So it's the same package whether you want to build a server that stays up and listens forever for connections, or you want to build a client to talk to servers, to go get or posts or whatever kind of requests to someone else's server. So this is clients. Let's skip over clients and let's go check out how to write servers. Does that sound good?
Mm-hmm.
Okay. So super fast way to do that is with examples. So you can click here and it'll scroll down to examples. And there's tons of stuff here. What I want to show is how to just run the thing. So hey, Ryan Jarvian, thanks for the follow. Appreciate that. So I want to just run a server that just serves nothing. Like it's just going to not listen to any requests, but it's going to be there. Listen. I should say this better. It's not going to have any support for specific HTTP paths. So you're not going to be able to go to like server / awesome HTTP path, but it will be listening for HTTP requests.
It'll just be listening for requests.
Exactly. Yeah.
Cool.
So that's here under this example. Listen and serve TLS. Actually, let's go to listen and serve so we don't have to deal with TLS yet. So I'm going to open this example. Oh, and this actually has a handler. Okay, so let's just look at this for now. So the inside part here that I'm highlighting, this is saying, okay, Go, I want you to listen on port 8080. And I want you to stay running forever. That's what listen and serve does. And this thing will return an error if something happened and the server stops listening. So that hopefully will never happen. But if it does, this log.fatal is going to see that error, print that error out, and then crash the program with a non-zero exit code.
Cool.
So let's just start with that. Let's literally just copy this over back into our HTTP server and do that. So I saved, and then my Go tool, my Go extension saw we're also using log, so it added that too. I just think that's super cool. I really.
That is super nice.
Yeah.
And so that's like we talked about in a previous episode. That's just the Go extension to VS Code.
Exactly. So that is
gets this.
Here. Just search for Go. You don't even need to type in Golang. It's one of the few times you don't need to type in Golang. And yeah, totally free. Everyone gets this. When you install it for the first time, it's going to install a bunch of other open source software that helps this thing do its magic behind the scenes. And then after that, you're good to go.
Cool.
So let's just run this. Hey, Ryan Jarvian, we're just glad to have you here, man. Or sorry, we're just glad to have you here. We love sharing. If you've got comments, questions, I don't know if you're here at the beginning. There's no question too small or big. We just love to hear from you. So let's just run it. Actually, let's go into our HTTP server folder. We're going to hit dot, which is going to say to the Go tool, this Go tool right here, that we want to run the main function inside of this folder. So dot, you can do dot slash if you want, but dot is shorter. I'm lazy, so we're just going to do go run dot. And now, Jennifer, this is what you were asking. Does it just stay up? So it's just waiting at this point.
Can we go to another little window and use our magic curl?
Yeah, for sure. So we're going to do curl localhost. It was listening on port 8080.
80, yeah.
And we get an HTTP response. Page not found.
Ooh.
So what it's saying is the server is running and accepting HTTP requests, but there's nothing that handles the slash path, like the home page sort of. So
Got it.
let's do that. Let's handle the home page. Let's write some code to actually do something when the home page, when a request for the home page comes in. And that is all of this code. So let's start with this line here. So I'm actually going to copy just this code. I'm going to bring it in, and then we're going to explain it. So the first thing is, you'll notice after this line, no other code will run, because this thing is just going to run forever. And if some bad thing happens and this thing stops running, we're going to crash the program. So you literally can't put any code here. If you put,
it won't see it.
Yeah. That's because the log.fatal line above will either, let's not write log.fatal, the listen and serve line above will run forever. And if it fails and stops running for some reason, that log.fatal function that wraps listen and serve will crash the program. So we've got this is called registering a path. So what we're saying is, call the HTTP package and then say we're going to handle a path, that's handle, with a function. So it's kind of like a callback. We're saying, okay, HTTP library, whenever a request for localhost port 8080/hello comes in, I want to execute this callback. So now the question is, what is the callback? So Oadia asks, thanks for the clarification. So where's the log written in the case that the server fails? The log is going to be written to the terminal, to the console that I'm running the thing in. It's going to be written to be specific, it's going to be written to standard error. But I'm going to put a log message here and I'll show you what the log looks like when it's not a fatal. Instead, when we just log out some information. So I'll show that in just a second after we finish up this line here.
Is it? What's the difference between handle and handle func?
Let's get to handle in a second.
Okay.
Let's do handle func, and then let's do this log, and then let's do handle. So in Ryan Jarvian, should log.fatal be indented, or is this common for Golang? This equals the current style of nesting. This specific usage of log.fatal, so this specifically calling log.fatal for any error that listen and serve returns, this is pretty standard for Go. But there are other cases, the kind of the general standard when we're not talking about HTTP servers, we would do this. Well, we would say error equals http dot listen and serve, and then we would go log.fatal error. So what this is saying is you run the server forever. If the server fails for some reason, get that error that it failed with. We hover over this, you can see it returns an error right here. Right there. So if it does return an error, we're going to assign that error to this ERR variable, and then we're going to log it out. We're going to log out the error, and then we're going to crash the program with a non-zero exit code. So let's go back to this callback. What the heck is this callback? Let's go back to our documentation. You can see they're passing this thing called hello handler. And now we've got this jam over here. we're saying hello handler equals a function. So you can actually do that in Go. You can say, I want to make a function and I want that function to go into a variable. So this is called a anonymous function.
Ah, okay.
So we're gonna focus on this for a lot of time so we can get this down because this is sort of a fundamentally yeah, that's I guess that's a good way to say it. A fundamentally powerful way, fundamentally powerful feature of Go. That can really make your life super easy. So yeah, Ryan Jarvian shorthand notation is exactly right. It can be kind of terse, which is kind of why I split it out. But it can really help. In this case, there's also an even more terse way to do this, but we're gonna save that for a future stream because um, it's hard to read if you're starting out, but when you start doing it regularly, it'll start being just a pattern that you recognize. You don't have to think about it. So we'll get to that in a later stream. Let's keep it like this for now. Um, but yeah, in a later stream, you can hold me to that. You can hold me to that. Just say, can we do the more compact error check, and then we'll just do it right then. So go for it, Jennifer. I know you have a question.
So when so the handle func, we've got our pattern, and then we've got the handler,
Mm-hmm.
and then the anonymous function.
Exactly.
So is handler a special term, or is this just like this is what we're calling this?
So you mean this handler? What they're saying here?
Well, in the function definition, like the spec for the function,
Oh,
uh,
okay.
the way that they. Okay, so yeah, so they're just calling it the handler
Exactly.
above. Okay,
And so
cool. So it's not something special. There's no specialness about it. It's just they're giving it a name.
that's exactly right. Yeah.
Okay.
So it's kind of a like a good practice to have it end with handler. But you don't have to. It's just good to see a variable called handler and then register that in your mind that okay, this is an HTTP handler.
Got it.
But what you do need is your function needs to be this. It needs to take in this http.response writer type, and it also needs to take in a pointer to an http.request. So
You and your pointers.
yeah, no, you should blame Go. Don't blame me for pointers. So I think we should have an episode where we focus in just on pointers.
Yeah, how about next week? Because these
Okay.
keep coming up.
Yeah, so I'm just going to write it down right now. So July 27th, 2020, pointers, the big bad topic in
If you
Go.
missed a previous episode, I talked about my fear of pointers. Because
So
of
yeah,
C.
we're gonna break them down. We're not gonna go crazy.
Awesome.
So there's a specific part of pointers in Go that make them less crazy. Let's call it crazy for now. Well, not
Yeah, it's
crazy.
crazy.
Yeah, not
But
crazy.
I don't
Make
know,
them less confusing.
or less traumatic. I
Yeah,
feel like every time I see the little star in a Go program, I'm just like, oh
yeah,
no.
yeah. I shouldn't say crazy. Sorry about that. It's less. Yeah, I mean, traumatic is an okay word. I think for me, it was intimidating when I first started Go. Definitely first started C as well. So
I'm just gonna say it out loud. No thanks to
no,
that terrible professor I had in college. That first one who gave me so much terrible shit about being able to program. So
yeah,
yes.
yeah.
there is total trauma associated with this. So we're gonna get over it. So
Yeah.
I'm gonna get over it.
No, there's going to be none of that. We're going to have a gentle introduction to pointers, and we're going to master them.
And
Mm-hmm.
references to pointers and
Mm-hmm.
pointer arithmetic. I don't know. This is all so confusing. I'm saying words.
Oh, let's see. Brian Jarvie, your Jennifer, your mic volume might need a boost. All right, we're gonna fix this for today, and then I'm gonna figure this out another time. I am going to do one of these. And I'm gonna do one of these. Jennifer, or Ryan Jarvian, how is Jennifer sounding now?
Hi. Can you folks hear me okay? Thumbs up.
Nothing. Oh no.
No.
Oh boy.
Be in silence, man. Oh, I'm back. I'm back.
A little better.
People say I'm back. She's back a little better.
Doubled. Yeah, that was because of Skype. We're gonna figure this out. Okay, better. Okay.
Oh, I do sound very soft.
Are we a little bit better? We're gonna get this figured out for real next week, but hopefully we can do this better for now for the rest of the stream. Maybe?
At least I don't sound like I'm in a tin can.
Yeah, that was last week. Tin can, yeah. All right, let's tough it out for the rest of today, and I'm going to get a mixer for next week to make this significantly better. No, Ryan Jarvian, don't say sorry. Please don't say sorry in this channel, ever.
Sounds makes for all the difference, especially for people being able to understand, and
Yep,
yes, it
exactly.
matters a lot.
Exactly.
We appreciate feedback.
Ryan Jarvian, no sorries. There are no dumb comments or questions as long as you follow the code of conduct, which is very easy to follow as long as you're being nice. So, no sorries. All questions, comments are welcome. So, we were talking about this. Well, we were talking about pointers. We're going to make pointers approachable and understandable next week. And I have, yeah, I wrote that issue somewhere just now. Yeah, pointers, all caps.
Yeah, I think understanding pointers, like, because so much code uses it. Like, I was looking at Porter code last week, and I was like, oh, joy.
Yeah. You can't avoid them in Go, but the authors, the creators of Go, they added some things and left out some other things for pointers that they make them a little bit easier to master. Well, they make them easier to understand when you're starting out, easier to master, and a lot harder to break your program with pointer if you're using pointers.
Okay, so
yeah,
I'm
excited about doing pointers next week.
It's gonna be great.
Yeah,
but right now, we're gonna get this line written.
Yeah, we're gonna get this line written. Yeah.
Okay, so we're gonna have a function, and
yeah, we're gonna copy this in here.
Okay, cool.
So we've got that. So this thing is saying, I'm going to write this function. This is what handle func requires. You need to write a function that looks like this. You can rename these like response and request. You can rename the actual parameter names to whatever you want, but they have to be a response writer type and a pointer to a request type.
Is this the right line? Can you go back?
Yep. Here, I'll do this. Right, yeah, this should be good.
Oh, okay. So you create. Okay. Okay, I see. It's separated.
Exactly.
So this is the hello handler, and then in handle func, you're gonna put where. Yeah. Okay.
Exactly. Yeah. So we've got our function. I'm gonna put this back on a one line because this looks a little bit weird to some people. So we're saying, all right, here's a function. The part that starts with func is called an anonymous function. So if it's anonymous, it would be helpful to assign it to a name so we can use it later. So that's what hello handler is. And now we're saying when you do localhost 8080/hello, run this code. So we're going to do response. And let's make this a little bit easier so we don't have to get into what io.writeString is. I'm going to comment that out. And I'm going to do response.write. So you can see there, response.write is a function. It's actually called a method that's assigned that you can call on this http.responseWriter. So this write method takes in a slice, a list of bytes. So in Go, a list is called a slice. And so that's how you represent a slice of bytes. You put open bracket, close bracket, and then you put byte, which is, it stands for the type that's in the list. So a list that can only have bytes in it.
Okay.
So what we really want to do is this. Actually, I should just copy this in. That would have been way smarter. So we can't do this because this is a string. So we have to convert the string to bytes. So let me do this. I'm going to copy it back out. We do hello bytes equals string. We still need this to be bytes. And the way you convert...
2 bytes.
No 2 bytes. I wish we had this. That would have been great. But Go has less of an emphasis on like methods. They have less of an emphasis on like object-oriented kind of patterns and more on having functions kind of floating around where you can pass any string into the function that converts to bytes instead of having to create a string and then call 2 bytes. So it's like a subtle difference. It doesn't really affect your daily programming, but it's just a different kind of pattern that Go chooses. So Audia, so inside the function there is IO. Where does that come from? We have response and request pass parameters. So IO, this is a brand new package. It's in the standard library. So the reason I commented it out was because it's a brand new pattern, but just at the very high level of what this thing does, it's saying, I want to write a string into this response. So the whole functionality is saying, take hello world and then send it to response. And once hello world gets sent to response, it's then sent down to the client, to my curl command. This way is a longer winded version of this one line function. So I hope that helps. We're gonna get to IO in sometime in the future, but I want to skip over it now because IO has so much power in it that I really want to make sure that we cover all of IO and not just like bits and pieces at a time.
And I feel like it just adds complexity where we just don't need that complexity right here.
Exactly. Yeah, exactly. So,
and so you also said that we have response and request pass parameters, and so those parameters we're then using them. So that's where the response comes from.
Yep. Yes. Exactly. So the naming kind of gives it away. Response is how you write stuff back to the client. Request is what came up from curl. So I always trip up on the order of these things because I always would say I expect, okay, request comes first and then response comes second. I always mess this up, so I have to remember. Yeah.
Which order is it?
Yeah, LN. I messed that up after 10 plus years, 15 plus years, I guess. I always mess that one up too. I need a script or something. Okay, so yeah, no 2 bytes. no dot 2 bytes. Instead, you do this. This is called a type conversion. But this bracket byte is a special function. There's no bracket anything else in Go. Actually, that's not true. Let me rephrase it. Bracket byte is a special function that only takes in a string and always returns a slice of bytes, a list of bytes. So
What does a list of bytes look like?
a list of bytes looks like this. So bytes in Go are, they have an alternate name called runes, R-U-N-E. So this is how you specify one of those.
So somebody was like Dungeons and Dragons, because like this was magic last week, and now we're doing some more magic. We got some
Yeah.
runes,
Are we echoing now?
incantations. I'm not hearing echo.
Anybody else on the stream hearing echo? No, let's just keep trucking. Yeah, so we've got a lot of magic going on in Go, but it's like, I don't know, it's more subtle magic. It's not in your face, I guess, but when you hit it, it is like, oh, what is this? And there's some things, we were talking about a couple weeks ago. We were talking about this whole thing where you kind of like see something when you're learning something new. You see something that you don't get, and you're like, I either have to stop and spend a bunch of time really wrapping my head around this one thing, or I have to kind of trust that it'll click later, and I got to just keep going. Bracket byte is one of those where it's like, what is this? Like, why is this a thing? But it's like, it exists, and it's just one of those things that, like, if you want to convert a string into bytes, just remember that is a thing that you do. And that's kind of it. So this is literally a list of a bunch of bytes that represents this string. Hello, comma, world, exclamation, and then have a new line at the end. So we pass in our bytes, and now we have an HTTP server that will run code when you do curl localhost 8080/hello. Should we try it?
Yes.
Okay, let's try it. So we gotta shut down our server and restart it to load up the new code. And now we're going to do curl localhost port 8080/hello. And then we've got some response coming in now.
Okay, so dun dun dun.
Dun, dun,
now
dun.
it's time to write a test.
Let's do it. So this is pretty untestable right now. Oh, actually, let's do a log real quick.
Why is this untestable?
So this is untestable because you can't test anything in here. If you were to do it, well, you can't call the main function from a test.
So you could do an integration test, but
Yes.
you couldn't do it. Got
Exactly.
it.
So you could write a Go program that builds and runs this program, and then you could use that same you could use this same library here. You could use the client functionality in here and then call it if you wanted to. But let's make this a little easier on ourselves. And let's do a unit test, because the unit testing functionality can get us almost all the way there, almost equivalent to writing an integration test with a lot less work. So before we do that, I just wanted to log out to show, I don't remember who asked about that. On port 8080. So it's as simple as that. If you call log.print, it prints to standard output and then it just moves on. Log.fatal prints to standard error and then crashes. I believe it's with execode 1, but don't quote me on that. I don't quite remember. So this is helpful too, because you notice here we started the thing up and now you're just like, well, what's happening? Like, is it like stuck? Did it crash? What happened? So when we do this, now we just see, okay, it made some progress. It's doing something. That's cool. All right, so back to testing. What we really want to do, the primary thing that we should test, at least to start, is this code. So it would be nice, like a full test would be, like we were saying, make sure that this handler gets registered for the for that path for /hello, and then make sure it's serving. But a great start is going to be right here to test the handler directly. So in order to do that, let's cut that out of the main function and put it out here so that now we can actually call this function. So there's a different way to write this function when it's outside of main. You don't have to make an anonymous function and then assign it to a variable anymore. Now we can take our hello handler and we can do the standard way of making a function in Go. So we can delete the hello handler, and now we can say func hello handler. We're saying to Go, I'm creating a new function, but it's not anonymous. This function is called hello handler, and you can use it anywhere inside of the main package. And now this function does the same thing, but now we can reference it down here because it's no longer an anonymous function. It's a named function. All right. So let's try running it again real quick just to make sure we didn't mess anything up. Head back over and do our curl. Cool. Okay, didn't mess anything up. Now for a test. Dun dun dun.
Can we talk through what's happening here?
Sure. So are we going to talk through the handler or the everything?
I don't know what to call it. So we have a Go application that we have run, and it's using HTTP.
Mm-hmm.
And so if we think about programs, and it starts line 1 and goes to the end.
Mm-hmm.
And so here we don't have a loop, or where do we, like, what how is this handling it?
Okay.
So we've got listen and serve, like that's how we have it running as a service.
Mm-hmm.
So, but we have this hello defined, like how is it all working?
All right.
So it's not like it's going to line 6, so it goes to line 16 every time.
Yes. So this right here, Go is going to skip over this first, then it's going to go here. So this is the very first code that Go is actually going to run. So once it calls this, then it's going to see, oh, okay, I've got to know what code is in here because I'm going to have to run this later after the server starts up. So if someone does a curl to localhost port 8080/hello, Go knows, all right, I'm going to have to run this function.
So is it kind of like putting a map in memory where it's like, if once you, so it's kind of like attaching something to this HTTP.
Yep.
And anytime it hits that particular, like anyone goes to hello, it's going to basically handle it.
Exactly.
And it's just going to repeat that code over and over again.
Exactly. It's going to, anytime you get a request in here, it is sort of like a map, sort of. It knows, okay, I need to go somewhere else, run that code. And then when I'm done running that code, the handling of that path for the HTTP request is done. So after it does that, there's kind of two steps. The first step is registering it, and that's like what you said, the map. And that happens once when the program first starts up. And then it goes down and it starts listening. The actual server starts up and starts accepting requests on port 8080. But then after that, it has this map already set up. So if a request comes in to that /hello, it goes and does a lookup on that map. And it says, oh, okay, I've got code that I can run for that path /hello. So let me go up and call that function. So it does that after the server starts up and after you make that request with curl. So yeah, how's that?
That's perfect.
Okay. Okay, so we got it running, we got some logging. Now we're going to check out some testing. So we saw some testing briefly earlier. Adia. Why do we need to cast the string to cast first before we write it in response? Why don't we do that directly by passing the string? You said byte. Which part did you mean byte?
So it's what we were talking about before. Like you can't just hand it a string; it has
Oh,
to be
okay.
in the form of byte.
Yeah.
So that's why we did that.
Yeah.
We
This
can't pass
thing,
the string.
yes, exactly. This thing, unfortunately, it only takes bytes. There's no there's no write string method, or really there's no way to write data down back to curl using this type. There's other ways to write a string down. You've got to use other libraries that are also in the standard library.
To be really clear, we're saying like to write on that response. Like it's anything that would be querying this. Like in order
Yes,
to respond to the request, it has to be in bytes. It's kind of like
exactly.
part of the protocol definition.
Exactly. Yeah. And Owadia, you're welcome for answering your questions. Keep them coming. Keep the questions coming. There's no question too small. There are no dumb questions. Yes. So, yeah, you have to pass bytes if you're dealing with this. Oh, there we go. If you're dealing with this type, you've got to pass bytes into it. And we can go check out that type as well. So we can search in here. We can go a response writer. And where is that? I can actually be more specific. Type response writer. There we go. So you can see, ignore the interface. It is similar to other programming language interfaces, but it's different. So ignore that for now. Here are the functions that you can, the methods that you can call on that type. So you can set headers before you respond. Like if you want to do a location header or a content type or whatever, you can write. So that's the one we used. You can write bytes. And you can write actual HTTP headers, like a 200 OK or a 301 redirect or whatever. So that's it. That's all you can do.
Cool.
All right. So we've got our handler. We kind of broke it out from the main function. So now we can call it directly. So now since we can call it directly, now we can write a test for it.
We can write a test.
We can write a test. We can write a test. We can write a test. We can write a test. I wish I had other cameras. I'll get some other cameras. I can do the different aspects. I go, we can write a test.
We can leverage Ryan's handle all the things, and people be able to move your camera around as you like. It's like dance party time. Let's
Yeah.
do some testing.
No, I'm gonna get like camera 1, camera 2, camera 3, camera 4, and then I'm just gonna toggle them. Yeah, doesn't yeah, Brian does do that. Brian Clark, right?
Well, no. So Ryan, not Ryan, Eric. Eric is talking about having a bot that lets
Hmm.
people interact. We can set up that bot and have it so people can like be like, it's testing time. Now you can trigger the camera
I
and
feel like we should use his bot. It does like the sounds. So we can do that one when it's testing time. Someone can put a command in chat and it'll go "dur-dur-dur," and then like there'll be the banner testing time. Yeah, we're gonna get that going.
yeah, and it'll be great because then you'll get used to whenever we write a function, testing time, and so then you'll miss it when you're not
Yeah,
streaming.
yeah, exactly. All right, so let's create our test file. So first
Cool.
thing,
Oh, so you're not gonna use that cool VS Code thing that we learned that like
how do you do that again? I remember. Oh
we
yeah,
we had someone teach us how did we do it. Oh,
that's
there we
right.
go. Dun
I
dun
remember
dun.
though. This created some crazy intense code.
We gotta train you out of this crazy word. We're gonna.
I'm sorry. Yeah, yeah, yeah.
It's gonna be a
I'm sorry.
process.
It
It's an
creates.
evolution.
I know. I know. I'm sorry.
It's very complex.
Yeah.
A lot of words. Let's do
So
it.
so this generates some intense code. Really
Let's do
like
it.
let's do it.
Yeah.
Oh, I need to delete this, I think. Or maybe it just
Well,
doesn't
let's just
work.
look at it. Well, no. Let's look at it.
Oh, but it didn't.
What did it do? Did it change it?
I don't think so.
Oh,
Oh.
okay.
Yeah, so we do have to delete it because I didn't do anything in this file. So let me delete this real quick. Delete permanently. Or you want to delete main underscore test? I do. Now we're going to generate our code, generate unit tests. So here we go. Strap yourself in.
Okay, wait a minute.
Look at this.
Wait a minute. Okay, so if I have something I'm working on and then I create a function and I do the generate test and then I modify it and then I have another function and I want to generate another test, it's gonna say I can't do this. It won't
I don't know.
Skeletor it for me. Okay.
Let's see.
I have a dog.
Dogs on streams is totally cool. So, all right, we're going to return a string. So we've got a basic function. Let's do it. Let's generate unit tests and see what happens. So it looks like, yeah, it skeletored out our other function too.
Okay, so as long as you initially Skeletor it, it's fine Skeletoring it in the future
Yeah.
if you make a modification.
Yeah.
That's good to know.
All the skeletors. Yeah, Ryan Jarvin, you got it. All this. Oh, is that? Yeah, you got it. That's right. All the skeletors. So, I mean, this code is intense though. Like, what is this? I mean, for real, this is not.
Okay, let's have a let's just let's look at it. Okay, so
So
it's a so
I feel like
it's
we
a
should write
function
a
of a
simpler
test.
test though.
We can totally write a simpler test. We're gonna just look at it
Okay.
for a second. Okay, I'm done looking at
All right.
too much.
Let me point out like two things though. Before, like, we are going to go and we're going to delete all this code from line 9 to 23. And then we're going to just start anew. But I'm going to point out actually three things. So, first thing, if you've got tests, they have to be in a file that ends with underscore test.go. That's Go says that's the rule. You got to do it that way. The second thing is your tests have to start with test, uppercase T, test. You don't need the underscore, but some people do that. It's up to you. But you gotta start with uppercase T, test.
Uppercase T test gotta be file underscore test.go.
Gotta be uppercase T.
Gotta be uppercase T. Gotta be uppercase T. I'm gonna remember this now.
I knew it. I knew it. That's you gotta do the rhymes for programming. So gotta be uppercase T. So we got end with underscore test, gotta be uppercase T. And then you gotta take in a testing T right there, a pointer to testing T right
You
there.
gotta get your T. Ah, this is what people are talking about. The T.
Get that T. You gotta take in a pointer to a testing dot T. So testing is
You
also
can't avoid them.
you can't.
Cannot avoid them.
You can't. It's not gonna happen. There's no way. But you just like all you gotta do for this before you understand pointers, you just gotta remember star testing dot T. Testing is in the standard library too.
Lots of sparkles.
Yep. You can call it whatever you want. But this
Which thing can you call it whatever you want?
right here.
Okay.
So we're gonna
So
do
it can be
T.
more useful than just T.
Exactly. It's
Got it.
for Go, this is the kind of the de facto standard, but that's whatever you want to call it is totally
So
cool.
if I think about this in terms of like what it is here, so I'm defining a function. Am I defining an instance of a test, or is it in this function gonna be the test suite?
In this function is going to be the test suite.
Got it.
You can do like if
The
you've
test
got
suite for a function.
yes. But if you've got like let's say you've got two different kinds of functionality that Hello Handler is going to do. Like for example, let's say Hello Handler can handle get HTTP requests and post HTTP requests. You could have test Hello Handler get and then a different one test Hello Handler post. That's totally legit. So the reason that's legit is because these are plain old functions. So all you have to do is make sure they don't have the same name.
Cool.
So all of this, I'm gonna blow it away, and we're gonna start from scratch. We're gonna do a test from scratch. How's
Okay,
that?
I thought we could keep like the function header. Are we not using that at all?
We're gonna keep line 11,
Okay,
but we're gonna get rid of line 12 to 26
that sounds perfect.
because this is intense. So let me do. I'm gonna go back to call
And
this.
this other function.
Oh yes. Sorry about that. All right, so we got this. I'm gonna go back to call this T. Is that cool?
No.
Okay. No. Okay.
Yeah. Well, let's call it something longer than T. It just like when we have one letter. I know it's the pattern, and I'm fine with the pattern, but like just for now, like
Okay.
have something that's like a little longer. Like it can be TEE. I don't know.
How about tea? Like you
Yes.
drink it. Okay. Totally legit. I am.
Is-
I'm totally on
Not
board with
going
that.
long, 'cause I just want to make sure our goofiness is like not confusing anybody.
Yeah. Let's take a like a 1 minute pause, maybe
10-second.
10-second. That's fine. I wish I had a timer. 10-second pause. 10, 9, 5. All right. So
We put people to sleep.
yeah, maybe we need to do a dance break.
Oh goodness, we could totally have little 30-second dance parties.
Yeah, we got to get some music in here. I'm gonna get some music in here for
The
sure.
problem with music is like it's so easy to get on the like get your stream like not okay. I don't know.
No, we
Too
got
many rules.
Creative Commons music. I can get some of that going.
Okay.
Yeah.
Creative Commons music.
That exists. It's a real thing.
I know, but it's not dance music. Unless it's like a beat.
Challenge accepted. Challenge accepted. I will find it. I will find it.
Oh,
Cool, cool. All right. Package main. We're in the same package as this thing. We have our testing from the standard library. We've got our gotta be uppercase T. We've got, excuse me, we've got our pointer to testing T, or star, let's call it that. We've got star testing.t. This one is super unhelpful as well, the .t part, but that is the Go type.
that is required.
Yes. So star testing.t. Yep. And then we've got our, we're calling that star testing.t, we're calling it T, TEA, like the one you drink. So when we run our test, Go is going to magically call this function for us. So let's just put like a tiny little bit of code in here just to like print something out, and we can just see it in action.
Okay.
So we're going to do t.log hello, gotta have that uppercase T. So let's just run it and let's see this happen. We're going to just see
run
that.
test.
Yep.
Click on that run test.
Oh, I forgot. Yeah. Run test. I keep doing it.
Wait, why is it okay?
Oh, it didn't print. I hate when that happens. It's okay. I will figure out the print thing in a second. But it's okay because we didn't fail. So that's the default, is the test passes as long as you didn't fail.
The test passes if you don't fail.
Yep.
I feel like it should be the test fails unless it passes.
That would be, yeah.
That
would be
evil,
nice.
but at least you know it's running.
Yeah. So you can pick up third-party test libraries and they'll do that for you.
Got it.
This is like those are all built on top of this, but this is like the fundamental. This is the most basic as well, but it's the fundamental Go testing facilities. But let's see it fail. You change it from log to fatal. You click on it again, and there you go. That's the fail. And it'll give you the line number, which is kind of nice. Gives you the test that failed.
So the line number is going to refer to the test
Exactly.
that failed. Got it.
Yeah. So it's saying, here's the file, main_test.go. Line 11 is where the actual failure happened. So cross-referencing that up to the code, we're right there. T.fatal. So we should test some real code, huh?
Yeah.
This isn't too useful for us.
Can it test that? So right now, if you call hello, it will print out hello world. So can we test that? So we want to know. We don't want to test things that we're taking on board from the library itself. So we don't need to test, is it running, right?
Right.
It's running. This is not a production test, it's a unit test.
Exactly, yeah.
So we want to make sure that our logic is getting tested. So there's got to be some way to say, okay, I'm expecting if you go to hello, like /hello on 8080, that it's going to be hello world.
Exactly. So what we're going to do is we're going to first delete this. What we're going to do is go in, and we're, like you just said, we're not going to test listen and serve. We're just going to call this function here between line 8 and 12. And we're going to make sure that this function wrote hello world into this response writer. And that's it. That's going to be the unit level test that we do. So,
Okay. So it's like it's almost like we're creating a brittle thing, but I think that's the only way to test it because it's like if we change it to be hello tea people, then
yeah.
you have to change the test.
Yeah.
But that's just the nature of this test.
Yeah. The nature of this one is like the only functionality in here is returning hello world. So there might be, I guess, depending on the use case of this handler, there might be a better way. Like we could make sure that it always returns a new line at the end. I guess that could be one, maybe something better. Adia, in other programming languages, we can't test private. Can we test private functions in Go? As I know, the function starts with lowercase. That's a private function in Go. It can't be called from the outside. Yes, that is correct. A private function in Go is also called an unexported function. So, private functions in Go are available in the same package, not just the same file. So all of the files that have package main at the top, they can all use all the other files private or unexported functions. So that's why I have my lowercase hello handler here. But if I head over to main underscore test.go, I can also use it here. And that is because we've got a package main here as well. So we can share our unexported or private functions. So Jennifer, how about we check our /n. Let's just check to make sure there's a new line at the end. How's
That
that?
sounds good.
Cool. All right. So we're going to definitely call hello handler. But we got to figure out what to pass it. Takes in this response writer and it takes in a star HTTP request. So we have to reach for another standard library package called HTTP util. I'm sorry, it's actually called HTTP test, not HTTP util. So heading down here, is it? No, it's here. So utilities for HTTP testing, that sounds good to me. And we've got two things here. Actually, we have three. So we've got a new request function that we can call that gives us back a request, kind of a mock or a fake request. We have a response recorder, which gives us back a mock HTTP response writer. So these two, here and here, will give us back this request and this response. And the response recorder, the one that gives us back the response writer, the response recorder will allow us to see what response my handler gave back. So that one is a little weird because we're creating this new recorder thing, this response recorder, but we're going to pass it in. When we call this function, we're going to pass it in here. Recorder. We're going to pass it in here. But this thing takes in a response writer. So there's a subtle difference there. So this is where we get into interfaces. And I think, go ahead.
I think we should do like time check. I should have said this 10 minutes ago.
Cool.
Because we're out of time.
Yeah, I always go over. I talk too much. Yeah.
But is this a okay place for us to pause and
Yeah,
reflect?
let me leave a comment here. Check out. So we will have a place to pick up next time from here.
Awesome. And do we want to actually talk? Well, so next week we'll talk about pointers. Do
Yep.
we want to continue from here as well next week, or just cover pointers? Will pointers take a whole?
I think that we should take the whole time next week and dive into pointers first. So actually, let me back up. I don't think we need to not do this code next week, but we should start by diving into just what is a pointer and then come back to this code and then use our new knowledge to figure out like what is star testing.t mean, that kind of thing.
Cool. Awesome. So
Let me commit this code while you are talking, Jennifer.
cool. So I have learned lots of cool stuff today. So we end our episodes, our streaming with a "Today I learned" or "In case you missed it" sort of thing. And if you want to share your "In case you missed it" this week, any projects you're working on in the chat, please do. We'll add it in the show notes, or anything interesting that you learned today. That's fantastic. Today I learned a little bit more about testing. So I learned about this package HTTP test. That is not something I knew about, and it's great to know that it exists. I have a little more clarity about sort of the structure here and thinking about using how would we implement a web server. Anything anyone else wants to share? Anything you want to share, Aaron?
Sure. I'll share a learn and in case you missed it. My in case you missed it will not have anything to do with tech. So I learned two things actually. I learned this io.writeString. I learned it because I had to explain it. I don't remember who asked the question, but I really enjoyed explaining it because I had to pull from other knowledge of Go to really understand what this function means kind of on the fly. That was awesome. I really appreciated that. Who asked that question? I can't remember. I think it might have been you, Oadia. I can't remember though.
That would be correct.
Oadia, cool. Thank you. So yeah, thank you, Jennifer, for correcting me. And thank you, Oadia, for the question. I really appreciated that. I also learned this. I have never broken this up into two lines. I always do the log.fatal and then I put the listen and serve right inside of it. So that was cool. I really appreciated that as well. In case you missed it, something cool that I discovered this week. Just yesterday, I went to a seafood place that is kind of one of those things where you say, I want this and I want some specific kind of sauce, and they mix it up for you. This one, they dump all the seafood on the table. And just, that's what it is. You eat off the table.
I've seen these. Usually they have like a plastic underneath, so
Yep.
so then they can just like lift it up and
Yeah.
bring in the next person. That's
Yeah.
awesome.
Yeah, I enjoyed that. It was a lot of fun to just eat with my hands and call it a day after that. A lot of cool stuff. And it was really well socially distanced and clean and just organized really well. I didn't feel unsafe or dirty or anything like that the whole time, which I really appreciated because I have not been out anywhere really for months and months and months. So I liked that.
I know this feels. I've been to the playground, not the playground, the park. I
Yeah.
have not playgrounds are like, I don't
Yeah.
know. That you would think they'd be okay because they bake in the sun, and if you could
Hmm.
just like schedule, like all the kids could schedule time to play at the playground. But at any rate, I forgot one of the cool things I learned today, in this week. So I learned, I'm just gonna typey. I learned about like this in last week in the Porter meetings. We were talking about this because like I hadn't seen this under a bar thing, and it was like in the way that it was used in it's like the unnamed
Hmm.
variable. And I was like, well, what is the pattern called where you do this, where you just want to get the third party effects of like
Hmm.
running it, and so it just fails your linter check. And so when I first saw it, I was like, is this like an anonymous function where you just don't care? But it's not. And then today we talked about anonymous functions. So it's like, oh, okay. So it's like I
Hmm.
keep picking up these little nuggets of Go, and it's great. So,
That is a cool one.
yay.
We should we should talk. I'm trying to think if there's a kind of a bigger topic that would cover that, or maybe we should just talk about that for a stream. That one's interesting.
Or we should do like a Go in 5 minutes on the little underbar thing, because
We
like that would
could.
be fun.
Yeah, we could do that. Yeah. Yeah. That'd be cool.
Cool.
All right. So, Jennifer and I will be back 1:30 p.m. Pacific on Wednesday. We're going to talk about cloud native technologies. We're going to work through our ongoing project with Dapper. Go to dapper.io if you're interested in that project.
Got a little JavaScript, a little bit of
Hmm.
Python, and a lot of Dapper.
Yeah, we're gonna. What do we leave off? Something concurrency in JavaScript. We were doing await, async and
Yeah, we
await. I
had
think.
Tyranny doing some awesomeness with us.
Yeah.
Saved us so much
Yeah.
time.
Yeah, so tune in for concurrency in JavaScript and cloud native everything on Wednesday at 1:30. Awadia, you're welcome. We are not all guys though, so try. You saw me struggling as well with the word CRAZY. So yeah, try to use folks here. We would greatly appreciate that. And yeah, so cloud native on Wednesdays. I'll be back with Go, building a search engine in Go at 10 a.m. Pacific on Fridays. So this
That
Friday we're gonna,
sounds awesome. I might
yeah,
like sneak on your show.
we are building a search engine. We're right now we are scaffolding out the API. We're gonna build a REST API. We're gonna build a JavaScript front end using the Svelte framework. This is a really cool framework. I'll put the yeah svelte.dev. Awesome framework. We're gonna use the Bing search API. It's the Microsoft Bing search engine. And then after we get to there, I don't know when we're gonna get to that, but after we get there, we're gonna branch out and go crazy. We're gonna start doing image search, and eventually we're gonna probably start crawling ourselves instead of letting Bing do it. Lots coming up there. That's gonna be a
Awesome.
year-long project or something like that. All done with live coding.
Wow, that sounds awesome.
Yeah. And then we'll see you back here next Monday at 11 a.m. Pacific. Anything else I forgot, Jennifer?
Nope. I think that's it.
Sweet. All right, everybody. We will see you soon. Take care.